This video talks about rational expressions. Rational expressions are fractions made of polynomials. First thing you need to know about these rational expressions is how to simplify them. For that, we're going to follow this idea. If you have rational expressions that when factors show common factors, such as in here, then you're allowed to eliminate them this way. Common factors, again, one on the top, one on the bottom, can be always eliminated, and will leave you just with a over b. And that is the way we are going to simplify rational expressions. For you to remember the steps here, step 1, factor, and by factor I mean factor as much as you can numerator and denominator. And step 2, between quotations, eliminate common factors. I will explain this to you via this example on the right. But in essence, this eliminate common factor means just eliminate common factors, one on the numerator, one on the denominator, right? One on the top, one on the bottom in general. Okay, so let's take a look at this first example. Simplify these rational expressions: x squared minus 9 divided by x squared minus 8x plus 15. Let's follow these steps. Step 1, factor. Factor as much as you can. So we're going to factor this guy. What should be the factorization of this guy? Well, notice this is just x squared minus 3 squared, right? So this can be further factored using difference of a square, but let's just write it for now this way. Now, what's the factorization of this guy? Factorization of this guy is x times x here. We look for two numbers whose sum is minus 8, whose multiplication is 15. Those two numbers are 3 and 5. However, since we want the sum to be minus 8, this has to be negative, this has to be negative as well, right? Good. Now, further factoring this difference of squares, we're going to have here x minus 3, difference of the bases, remember, multiplied by x plus 3, sum of the bases. Now, second step says eliminate common factors. So you look for factors that are common on the top and on the bottom. Here you notice x minus 3 is on the top, x minus 3 is on the bottom. So this is precisely where we cancel, right? We eliminate. So once you cancel, you are left with x plus 3 over x minus 5. And this is the final answer. Okay, let's move on. Let's go to the next page. Here I'm going to show how to multiply rational expressions. Rational expressions are fractions made of polynomials, so the way you multiply them is similar to the way you multiply fractions made of whole numbers. So basically we multiply the numerators, then we multiply the denominators, and of course once you have this form, you are supposed to simplify the way we learned before. So for you to remember, these steps are: first step, factor as much as possible, numerator, denominator. And step 2, apply formula, which is this formula, right, for the multiplication, and eliminate common factors as before. Okay, so let's follow this example. It says multiply 4x minus 16 over x squared minus 1 times x squared minus 5x minus 6 over 2x minus 8. Step 1, factor as much as possible. So start here. Let's factor this binomial. Greatest common factor 4, so 4 times x minus 16 divided by 4 over x squared minus 1. Notice that the number 1 is the same as 1 squared, so follow factorizations via difference of squares. So you will get difference of the bases, x minus 1, times sum of the bases, x plus 1. Okay, so that was the factorization of this guy. Now here, times. What is the factorization of this? Well, remember, for x squared having leading coefficient 1, we write x here, and we look for two numbers whose multiplication is minus 6, whose sum is minus 5. After some trial and error, you will see that the number should be 6 and 1. Which one should be negative so that the sum is minus 5? Well, the negative one has to be the one with the larger value, this guy. This should be positive, so negative 6 plus 1 should be minus 5. Good, so this is the factorization of this guy. Now let's factor this. Greatest common factor 2 out. 2x divided by 2 is x minus minus. 8 divided by 2, 4. So this is the factorization of this guy. Now apply formula. The formula is going to simply put these guys together, right? Via this dot on the bottom. So we do that. 4 times x minus 4 times x minus 6 times x plus 1 over x minus 1 times x plus 1 times 2 times x minus 4. And this step can really be avoided because in essence you're just putting the factors together, right? In practice, you can just go ahead and eliminate common factors even when you are here at this stage, right? So just eliminate common factors, the top and the bottom. This guy, x minus 4, appears down here, so we're going to eliminate these two. This guy, x plus 1, appears up here, so we're going to eliminate these two guys too. The number 4 and the number 2 can be simplified. 4 divided by 2 is 2. 2 divided by 2 is 1. So this becomes 2. So finally you will be left with the following 2 here multiplying x minus 6 over here, this becomes 1, disappears, right? Just x minus 1. Now, this should be considered to be the final answer. Mathematicians like factor form when it comes to present final answers. Most of the time, 95% of the time, the answer will look like this. Some rare cases, you might have to expand this, right? 2x minus 12, but again, that's very rare. Most of the time, this will be the final answer. Okay, let's move to the next example or to the next situation, which is division now, division of rational expressions. So let's take a look at this. Division of rational expression is done in the same way you do division of fractions made of whole numbers. So a over b divided by c over d is the same as a over b. You keep this guy as it is. Then you change division for multiplication. So change this. And then you change the second fraction for its reciprocal, meaning what you get when you flip this second fraction. So c over d becomes d over c. This is also known as keep change with a mnemonic device. So in essence, you turn the division problem into a multiplication problem. So for you to remember the steps to do this, follow this. Step 1, write division as multiplication. So keep, change will allow you to do that, right? Change division for multiplication first, even before factoring. Step 2, factor as before, right? Once you turn this division into multiplication, you factor as before. And step 3, eliminate common factors, meaning eliminate common factor on the numerator, denominator, top and bottom, even if the fractions show different components repeated, not necessarily in the same fraction, right? You can always eliminate. Let's explain this via this example here on the right. Divide x squared minus 3x minus 18 over x squared minus 9. Divide that by x squared minus 4x minus 12 over x squared minus 3x. Okay, step 1. Even before you factor, do keep, change. Turn this division problem into a multiplication problem. So we do this. We keep the first fraction as it is. We change division for multiplication. This dot, remember, represents multiplication. And then we flip, or we take the reciprocal of this second fraction. So this guy goes at the top, this guy goes on the bottom. 4x minus 12. Okay, now you have a multiplication problem, right? So now step 2, factor. Factor as much as possible all the components that you see here. So let's factor this guy first. What is the factorization of this? Well, since the leading coefficient is 1, then this factors as x here, and we look for two numbers whose multiplication is negative 18, whose sum is negative 3. After some trial and error, you will see that the numbers are 6 and 3. I want the sum of these two numbers to be negative, so the negative number should be this, the one that has the bigger values, 6, and then this should be positive. So this is the factorization of this guy. Now let's factor this guy on the bottom. Not hard to see this, that number 9 is the same as 3 squared. So we're dealing with x squared minus 3 squared. This guy 3 squared. So x squared minus 3 squared factors as x minus 3 times x plus 3, right? We are following here factorization via difference of squares. Okay, times here, what's the factorization of this guy? Well, x out, x squared divided by x minus 3x divided by x, 3, close parentheses. So this is the factorization of this guy. And finally, what is the factorization of this? Well, x here, we look for two numbers whose multiplication is negative 12, whose sum is negative 4. After some trial and error, the numbers would be 6 and 2. Again, you want the sum to be minus 4, so the bigger value should be negative, the smaller value positive, so you get this. Now it's time to eliminate common factors. One on the top, one on the bottom. They might not belong to the same fraction, right? So it's okay. Alright, so this guy cancels with this guy. This guy cancels with this guy. X plus 3 cancels with x plus 3. What is left? On the top, the only thing left is x. On the bottom, the only factor left is x plus 2. So then this is it. This should be the final answer.